Good evening and welcome back to RockPyle Tutors. Today we're going to do a quick video on adding and subtracting fractions, and is my first video with a shout out. Shout out to Madison, who asked me to make this video and one on multiplying and dividing. So, when we are adding fractions, we'll start with that. My first step is going to be make your denominators match. Then, and only then, you can add the numerators. And then the final step, which is true for any fractions question, is can I reduce that fraction? Is it a proper fraction? And do I need a mixed number? Or all of the sort of cleanup stuff you have to do with fractions. So we are going to start with more relatively easy ones. So we're going to start by adding fractions that have the same denominator. So for instance, I'm going to do 1/3 plus 1/3. So my first check, do I have the same denominators? Yes, I do. Then I can add the numerators and I'm going to get 2/3. All right, similarly, if I do 2/4 plus 1/4, what am I checking? Checking my denominators. They're good, so I can add and I get 3/4. Okay, and we're going to go one more, 5/8 plus 2/8. Guess what I'm doing? You got it. Check my denominators, they're good, add them, and I get 7/8. All right, what happens if we've got multiple numbers? Now, a quick note, as we're doing these, when I put the number up there, right, I'd like you to pause the video, try it on your own, and then watch me finish, especially as we get to the more complicated ones. So I'm going a little quickly here because I think you'll be able to follow this, but when I get more complicated, pause the video when I put the problem up, work it yourself, and then hit play. All right, so let's try looking at multiple numbers. So if I do 4/9 plus 3/9 plus 1/9. You got it. I'm going to check my denominators. They're all 9, so I'm good. 4 plus 3, 7, plus 1 is 8. 8/9. So it's relatively simple when we have the same denominator, and a proper fraction is when the numerator is lower than the denominator. So that's your numerator. Tells you how many of the things you have. And the denominators, which is like a denomination of coin. How many pennies do I have? How many ninths do I have? How many quarters do I have? In this case, we've cut things up into ninths, and we have 8 of them. So we have 8/9. Now, let's add something like this. If I go 4/5 plus 1/5, check my denominators, we're good. 4 plus 1 is 5/5. Okay, the numerator is not smaller than the denominator, so I've got a problem here. This is called an improper fraction. And so what we do with this is we either reduce it or when they're the same, so in this case we're going to reduce it, we're going to divide both top and bottom by 5. We're going to get 1/1, and I think you've already seen that the answer is 1. And so an improper fraction starts when they're the same, which is equal to 1, and it's going to go up. If I were at 7/5, right, I would see how many 5s can I take out of 7? That would be my whole number. And if I take 5 away from 7, I'm left with 2/5. Now this is because 7/5 is equal to 5/5 plus 2/5. So I break up 7/5, and then I know that this becomes 1. So now I get 1 plus what's remaining, 2/5, which is 1 2/5. So we're going to have to be able to be pretty good at making mixed numbers when needed, and they will be needed. All right, let us look at another one like that. So if I do 2/3 plus 1/3, right? Check, check. 2 plus 1, 3/3. What did we just say about that? We said that's going to be equal to 1. All right. And then next, what if I, instead of adding 2/3 to it, or sorry, instead of adding 1/3 to it, I'm going to add 2/3. Right? Check my denominators, we're good. Add them up, I get 4/3. Okay, that is an improper fraction. So I'm going to say how many 3's go into 4? One of them. So I'm going to write 3/3 plus 1/3. That's going to become 1. And so my answer is 1 1/3. So this is all fine. Now we know how to add fractions. We know how to deal with them if we end up with an improper fraction. And so the next thing is, what do I do if I add fractions and mix numbers? So if I give 1 3/4, let's say, plus 3/4. What do I do here? So first, I'm going to add the whole numbers. So for my whole number is 1 plus, there's no whole number here, so I have 1. Check my denominators, we're good, add them, and I get 1 6/4. So I have an improper fraction for the fractional part of my mixed number, so let's explore that. This is going to be that 1 plus, and I'm going to do the same thing. I'm going to break that 6/4 into a 4/4, and what's left after I take 4 of them away? 2/4. So that is going to equal, right? This goes away and is 1. So now I have 1 plus 1. So the whole number from the fraction, from the improper fraction, gets added to the whole numbers that you started with. So this is going to be 2 2/4. And we're done. Are we? No. We have 2 even numbers. We can have to look. Step 3, can I reduce? That's one of the questions. So yes, I can reduce, and I'm reducing 2/4. I'm going to divide each of these by the same number. And so I get 1/2 for the fraction, which means my entire answer is 2 1/2. All right, if that doesn't make sense, go back, watch from the beginning of this problem again. All right, but we'll do another few examples like that. So how about, what am I doing? That's not what I want. I want 7/8 plus 3 1/8. All right, so I'm going to add my whole numbers, 3. Check my denominators, we're good. 7 plus 1, 8/8. Now, I know I have an improper fraction here, so I need to figure that out. And 8/8 is 1, so it's going to be 3 plus 1 equals 4. And let's do one with a couple of whole numbers. So here we go. I have 5 11/12 plus 3 9/12. All right, everything looks good. First thing I'm going to do, I'm going to add up my whole numbers, and I'm going to get 8. Check my denominators. Good. They're the same, so I can add my denominators, and 11 plus 9, I'm going to get 20/8. Now what do I have? Now I assess step 3. Can I reduce? Yeah, I can also reduce here. So if I see that 20/8, let's divide both sides by 2. That's going to become 10/4. And look, I still have 2 even numbers, so I've got another 2 I can divide, and I can get 5/4. So now I have turned 8 20/8 into 8. I didn't do that right, did I? If I divide 10 by 5, I've also got to divide 10. All right. Let's go back. Okay, let's do the next one where we have a whole number in both of the mixed numbers. So we are going to do 5 and 11/12 plus 3 and 9/12. All right, talk me through the steps. First thing, actually, why don't you pause here and give it a shot yourself and then come back. Okay, now we're back. We add the whole numbers first, and I get 8. Check my denominators, we're good. Add the numerators. 11 plus 9 is 20/8. Now we've done the combination, and we have to do our cleanup work. So can I reduce this fraction? Is it a proper fraction? What do I need to do? I need to do both in this case. So let's reduce this fraction. So if I see that both of these have a 2 in them, I can reduce 20/8 to 10/4. And then look, I still have even numbers, so I can take another 2 out, and I can get 5/2. So this, 8 and 20/8, becomes 8 and 5/2. And now I've got this reduced, but it's still an improper fraction. So I need to break that up into how many 2's can I get out of 5. So I'm going to go 8 plus, here we go, there's one of them. That leaves 3/2, so I can get another one, plus 2/2, plus that last 1/2, because these are going to equal the 5/2. So now this becomes 1, this becomes 1, and my total answer becomes 10 and 1/2. Right? Looks a little complicated, but with practice, you guys will get there. All right, shall we do one more of these? 8 and 9/16 plus 7 and 5/16. What am I doing? Whole numbers first, 15. Check my denominators, we're good. 14/16. What do I do with this? Look at the fraction. Is it proper? It is proper because the numerator is less than the denominator. Is it reducible? It looks like it can be. I see they're both even numbers. Again, 2 is the easiest one to see. If it's an even number, they're both divisible by 2. So this is to become 15 and 7/8. And I am done because I have a proper fraction and I've done all my work. All right, good job. All right, now that's addition in a nutshell. Addition is simpler. Subtracting is similar, but it's got one more potential step. Okay, so with the subtracting fractions, we do the same thing. Step 1, we make the denominators match. Then step 2, can I subtract the denominators? What does that mean? Well, let's take a look at it. Clear all this mess. All right, so if I have 3/4 minus 2/4, right? What are my steps? Denominators, check, we're good. So now 3 minus 2, that works. So I get 1/4. Similarly, if I have 4/5 minus 2/5, right? Again, denominators are good. I can subtract 4 from 2, so I get 2/5. Right? Those are all pretty straightforward, and they're essentially the same as the addition that we did. Where it's going to come into play differently is when we start adding mixed numbers. So let's take a look at first, what does that mean? So 3 2/3 minus 1/3. What do I have? So I can't start with the whole numbers. I'm not ready yet. I need to take care of my fractions first. So when I look at these fractions, denominators good. 2 minus 1, I can do that. That's okay. So that's 1/3. And now I can subtract 3 minus 0, because if there isn't a whole number, it's going to be 0. And I get 3 1/3. But what happens if I switch the fractions here? So if I have 3 1/3 minus 2/3, all right, let's walk through it. First, I check my denominators. We're good. And now 1 minus 2. Uh-oh, I can't do that. So I need some more thirds. Where can I get more thirds? One of the places, the only place in fact, is from the whole number. So remember, if I had written this as 10/3, we would have turned that into a bunch of 3/3, and there'd be 3 of them, plus that 1/3 that's left, right? And then each of these becomes 1, and I get 3 1/3. But when I need more thirds, I can go backwards here and take one of my 3's. Where are we? So here's the transformation I'm going to do here. 3 1/3 is equal to 2 plus 1 plus 1/3. And now I need thirds, so I'm going to break this number up, and I'm going to make it 3/3, which was the opposite of what I did here. And now I have an improper fraction, but I want an improper fraction here. So that becomes 2 4/3. This is the key for subtracting fractions and mixed numbers, is that we've got to be able to convert a whole number into as many of whatever fraction. In this case, I needed 3/3. So I converted one of my whole numbers into 3/3. That gave me 2 4/3. And now, right, look back up at the original problem, right? Here, I turn this into 2 4/3 minus 2/3. And now I'm back. Can I subtract the denominators? Yes, I can. So this is going to be 2/3. And because I borrowed 1, I've only got 2 whole numbers left. And that is how you borrow in subtracting fractions. All right, let's do a few more of these because they're a little more complicated. And I do want to make sure that you do this practice yourself. All right, so we will... What are we doing? Okay, here are the problems. So let's say I have 3 1/4 minus 3/4. All right, step 1, you must be used to this by now, matching denominators. Bingo. So can I take 1/4 and subtract 3/4? I can't. So what am I doing? I'm taking this and I'm turning it into 2 plus, in this case, I want to break it into fourths. So it's going to be 2 plus 4/4 plus 1/4. And these now become my fraction. So this becomes 2 5/4. And now I can subtract the 3/4, and I get 2/4, and the whole number comes down as 2. What do I need to do for cleanup? It's a proper fraction, but it's not in its reduced form. So I want to divide both of these by 2, and I'm going to end up with 2 1/2. All right, here's another one, and we're going to do 3 minus 1 2/3. All right, we got a bit of a wrinkle here. So how do I ask myself, can I subtract the fractions? I don't even have any. So I can make it look like I have 0/3. That's really what 3 on its own is. It has no fractional part. But now I can see that I can't take 0 and subtract 2 from it. So I have to do my borrowing. 3 becomes 2 3/3. And so this becomes 2 3/3 minus 1 2/3. Now I'm good. I get 1/3 there, and 2 minus 1 is 1. So 3 minus 1 2/3 gives me 1 1/3. All right, let's do one more like this. I know this is quick, but hopefully you can go back and check it if you're not following, if you can't do these on your own. So this one I want to make sure you check yourself and stop. So I have 8 5/16 minus 4 11/16. Okay, fractions first for subtraction. Check, check. 5 minus 11. Can't do it. Where am I going to get some 11s or some 16ths? I'm going to take this 8 and I'm going to steal one of them and I'm going to turn it in to 16/16. So 8 becomes 7 16/16. Now I add to these and I get 8 21/16 minus 4. I'm sorry, back it up. What's my whole number? I borrowed, so I have 7 21/16 minus 4 11/16. Now I can subtract my fraction, so I get 10/16, and 7 minus 4 is 3. What do I have here? A proper fraction. Can I reduce it? Yes, I can. So 3 5/8. Make sense? That's pretty much all you need to do if you start with denominators the same. Now what we're going to do is we're going to look more into step 1. When they don't match, what do we do about that? Now we are going to deal with fractions where the denominators are not the same. And the biggest skill we need to do is to be able to convert fractions to whatever denominator we choose. So let's do the simple one. If I think about a unit, there's 1. I'm going to cut it in half. So each of these is 1/2. Now let's say I want to change denominators. Right? Let's say I cut each of those in half. So I'm going to take each piece and multiply by 2. And whatever I do to the top, I have to do the same thing to the bottom. So I multiply 2 by 2 and I get 4. And so what we're saying is as long as we do the same thing to the top and the bottom, the value is the same even though I'm showing it in different ways. So let's say somebody dared me to do this in 20ths, right? What is 1/2 in 20ths? Well, let's see. How do I get from here to here? That's times 10. And whatever I do to the bottom, I'm going to do the top. And that's 10/20. And so that, how to change fractions into whatever denominator you want, that's how we do it. We multiply or divide by the same thing to top and bottom, and then we've kept the value the same and just changed it into a more convenient way. So let's do a couple of problems like this, and I'll show you how I like to set them up as well. So if I have 1/2 plus 1/4, get that more in the center. So first I do is I check my denominator. I'm no good. So now I'm just going to draw 2 fraction lines over here, and I need to figure out what denominator do I want to work with, right? So in this case, the right answer, the simplest answer, is I want to work in fourths because 4 is a common multiple of both of these, and it's the least common multiple. So 4, to get to 4, I multiply by 1, so I keep the same number up top. 2, to get to 4, I'm going to multiply by 2, So up here, I'm going to multiply by 2, and I have 2/4 plus 1/4, and now I can add that together and get 3/4. All right, so identify if we need to change denominators, and then pick a denominator. So let's do 2/3 and 1/6. And I'm going to add them. Denominators don't match, so I'm already going to come over here and know I'm going to make a conversion to both of them, but I'm going to rewrite them with the same denominator. Right? In this case, 6 and 3. The least common multiple is 6, so I can work in sixths. Times 1, times 1, and times 2, times 2. So now I add them, and I get 5/6. Get the idea? In this case, we've only needed to change one of them. Next, what happens if we have to change both of them? So let's say we have 3/5. Where am I? 3/5 plus 5/8. All right. Okay, my denominators are not good. So I need to figure out a denominator that will work for both of these numbers. And the easiest way to do it is to write the two factors in a chart here. And then I'm going to move down the multiplication table for the bigger one. And I need to include this first one when I check. So my question is going to be, does 5 go into 8 evenly? It does not. Next one up is 16. Does 5 go into 16? Nope. 24 does not work. 32, nope. And 40. 40 does work because 40 divided by 5 is 8. 40 divided by 8 is 5. And this will always work. If you multiply the two denominators together, that will always give you a common denominator. It won't always give you the lowest, but we'll show you how to do that. So 5 to get to 40, multiply by 8. So I do the same thing up here, and I get this to be 24/40. This one over 40, what am I doing here? Multiply by 5. 5 times 5, 25. So I've converted both of these fractions into a denominator that I can work with because it's the same, and now I can add them, and I get 49/40. Let's do our check for cleanup. Improper fraction. What do I need to do? I need to make it a mixed number. So how many 40s are there in 49? There's one of them. And if I take 40 out, I'll have 9/40 left. Check this. Can't reduce that. So life is good. And I've got the answer 1 9/40. So that is how you change denominators. So multiplying them together will always work, but it can also be very messy. So if I look at these are all too easy. I want difficult ones. Well, I guess I'll make my own. So if I have 3/12 and plus 7/8. How do I do that? So I don't have common denominators. If I multiply them together, right, I'm going to get 96. So I can work together in 96s. And to get there, this is times 8. This is times 8. So this is 24/96. Now, to get to 96, I'm going to multiply by 12. 7 times 12 is 84. So I convert both to 96ths. I add them, and I get, what's that, 108/96. And now I've got some reducing to do. So I'm going to go, okay. So now we've created 108 over 96 and we need to reduce it. So I see a 2 there. So I can divide both top and bottom by 2. And I get 54 over 48. Both are still even. So I can turn that into 27 over 48. So again, you can always reduce by multiplying the two together, but it will usually require some reduction over here. The other way to do it is to go up the times table of the larger value. And so 12, I have to check this one first. So 12, 8 does not go into 12, but at 24, I've found my lowest common denominator, 12 times 2 and 8 times 3. So now I'm going to redo this with 24ths and 7/8 into 24ths. So 12 times 2, 3 times 2, I have 6 over 24 there, 8 times 3, 7 times 3, 21, and that is 20, I did it again, 27 over 24, which does match because this second step, I made a mistake. Second step, I didn't divide. So when I divide 54 by 2, I also need to divide 48 by 2. And now my answers match. And so again, you can find the easiest answer, which is multiplying them together, but you might have to reduce. Or you can do this step, find the lowest common denominator, and then when you're done, you won't have to reduce. All right, and that is the quick step about common denominators. So let's do a few problems like that. And we'll throw in some mixed numbers too. So we may have to add or subtract. So let's look at 8 and 2 over 3 plus 4 and 1/2. So what am I going to do here? Because I'm adding, I can just add my whole numbers first, but now I need to figure out what I'm going to do with the denominator. I like the multiplication table one, so I have 3 and 2. 2 does not go into 3, so I go up to 6. 6 works. So that tells me I'm going to work in sixths. So I immediately rewrite the two fractions here. Now let's figure it out. Times 2 is 4, times 3 is 3. Now I can add. So I get 12 and 7/6. Oh, you say that's not a proper fraction. So what do? I'm going to take 6 and make 1. And then what's left is 1/6. And that is going to get added back to the 12 for 13 and 1/6. All right, subtraction works the same way. So subtraction, once we get to a common denominator, so 9 and 7/8 minus 5 and 3/4, what am I going to work in? All right, if I go up the eighths, 8 will work, so I'm going to stick to eighths. And so this becomes 9 and 7/8, and this, so times 2 is going to be 5 and 6/8. Now, for subtraction, can I subtract the numerators? I can. So 7 minus 6 is 1/8, and now I can do 4 and 1/8. So now let's do one where I have to borrow. So 9 and 1/8 minus 5 and 6/8. So, sorry, 1/8 and 5 and 3/4. What denominator am I going to use? That calculation is the same, whatever I'm doing. So I'm going to make eighths. So this is going to be 9 and 1/8 minus 5, and times 2 is 8, times 2 is 6. Now, 1/8 minus 6/8, I can't do that. So what was I going to do? I'm going to come over and I'm going to break up the 9 and I'm going to make it 8 plus 8/8, which is going to make the problem now 8 and 9/8 minus 5 and 6/8. Fractions first. Now I can subtract. I get 3/8. 8 minus 5 is 3, and I have 3 and 3/8. All right, I think we are going to end the video there. I hope you enjoy it. Madison, I hope you do well in your test coming up, and I will see you guys soon. All right, and that is where we will end this lesson. Hope you learned something, hope you enjoyed it, and remember, if you're looking for tutoring for math or test prep, find me at RockPyle Tutors.com. Thanks.